Welcome. In this video I'm going to show you how you can obtain the Wilcoxon signed rank distribution using Python and the iterative function. In this video I'll simply focus on how to obtain the distribution. I have a separate video that explains more about the concept. The fastest way I think would be to just install my library. It actually has a function to obtain this distribution. But if you don't like to do that, then you can do it what I call the hard way. And in this case, we're going to be using the recursive method. I have a separate video on the enumeration method. This method is actually using a recursive function. The advantage here is that with the enumeration method, you have to calculate all of the probabilities. With the recursive method, you can just only do it for a specific one. Downside is it might take longer if the sample size is very large. So this is the scary looking formula. It's actually the sum of ranks frequency given x and y. X is usually the specific value and y is usually the sample size. It's going to be 0 if x is less than 0, 0 if x is greater than, and then the sample size plus 1 over 2. It's going to be 1 if the sample size is 1 and x is 0 or x equals 1, and it's going to be this separate sum of rank frequency function if y is greater or equal to 0. And this is where the recursion occurs, so this new one will be this formula. This part over here is simply the binomial coefficient, and the exclamation sign is the factorial. Now note that this binomial coefficient, if the bottom one is actually 2, is simply n, or y plus 1 is actually y times y plus 1 over 2. This should have been a y, so let's fix that. Y, and that should work better. Alright, so we can actually do all of this in one small function. So as the formula implies, if x is less than 0, then it should just return 0. Else, if x is greater than this one, it should return a 0 as well. Else, if y is 1 and x is 0 or x equals 1, so that's this one over here, then return a 1. And in all other cases, if y is greater than 0, then you just return this same function again, but then x minus y, y minus 1, and that's exactly this part, and the srfx, and then y minus 1. So if we load this in, and we load this additional function, then we can check it with an example. Let's say if we have a sum of ranks of 3, we can actually print the sum of rank frequency of 3. And let's see. Sorry, we don't have this one, of course, and that's from a different one. So let's do it like this. And n is not defined, so we also need an n. So let's say a sample size of 6. And then the sum of rank of frequencies is actually 2. Right, now this is just how many counts there are, but we need to divide this by the total sum of all counts. So to do that, we can simply divide it by 2 to the power of n. So if we do that, we have the probability mass function, and turns out if you have a sample size of 6 and a sum of rank of 3, and there's a probability of 3% of having something like that. The cumulative one is simply to iterate over all the probability mass functions for the same sum or less. So we can simply do that in one go, and therefore the probability of having a sum of rank of 6 or less, 3 or less, if the sample size is 6, is about 7.8%. Alright, I hope this was helpful, and thank you for watching.